problem has been solved and I am going to take my class. So please be careful. I am going to read the things you are supposed to be concentrate on the topic. We know that light has a wave character as well as particle character. Here it has written light has a wave character and particle character. Depending on the situation, one of the two character dominates. The phenomena of interference and diffraction can only be understood in terms of wave theory of light. There are some phenomena like photoelectric effect which can be only understood in terms of particle theory of light. What I say, the light has a dual nature. Sometimes it behaves as waves. Waves means uh, its motion is wavy nature, like this, and sometimes it behaves like a particle. Particle means it will travel in a straight line. Particles. There were many theories regarding the light. One theory was given by Newton called sparkler theory. Newton has assumed, Newton said that light has a particle nature. But some phenomena discovered like diffraction, interference, which were not be explained on the basis of particle theory of light. There was a person, Huygens. Huygens said that light has a wave nature. He said that light has a wave. Light moves in form of waves. Okay, sir. Okay, sir. Okay, got. Now, there was a person named Huygens. He said that light has a wave nature. Wave nature means it will travel like waves. But still there was some phenomena like photoelectric effect and Compton's effect which cannot be understood in terms of wave theory of light. Then scientist has concluded that light has a dual nature. Sometimes its wave nature is dominant and sometimes its particle nature will be dominant. Okay, and the topic is I am going to study here is photon theory of light. This is the particle nature of the light, photon theory of light. And in photon theory of light, we will study about the particle nature of light. Here, see carefully. The particle of light have several properties in common with the material particles and several other properties which are different from the material particles. The particles of light are called photons. Some important properties of photons are listed below. He's saying that we know the material particles. Material particles means those particles having some finite mass. We have seen the chalk, break the chalk into smaller particles, into smaller particles. Can consider the very tiny particles. It is known as material particle. Particle means point size object. When we say particle, it means point size object. Then, guys, material particle is different thing and light particle of lights are different thing. First, some properties are common and some are not common. The material particle have some finite mass, but the particles of light has not any rest mass. And the properties of light are called as photons. We call them as photons. And some properties is given. I am going to teach you step by step and you are required to focus on the topics. A photon always travels at a speed of light. We know that any material particle cannot travel with the speed of light. No material particle. Only photon, the particle of light, can travel with the speed of light. This is given the exact speed of light 299,792 and 45. This is exact speed of light, and we approximately say it is 3 lakhs kilometer per second, 3 lakhs kilometer per second in vacuum. If we change the medium, the speed of light will be changed. The speed of light depends upon the material property of the medium. The material property is this. This is the speed of light in vacuum, and the speed of light in any medium can be given as this. Epsilon is permittivity of the medium, that is called as electrical property of the medium, and mu is permeability of the medium, called as magnetic property of the medium. One time it has been asked the parameters on which the speed of light depends. The speed of light depends, guys, only on the electrical and magnetic properties of the medium. This epsilon denotes electrical property of the medium. This mu denotes the magnetic property of the medium. One thing which I am going to explain you, photon, the particle of light, traveled with the speed of light in vacuum. Okay, and this is true for any observer, whether observer is at rest, or observer is moving. Suppose observer is moving with speed c by 8, then even he will feel the speed of photon as the speed of light. We will not apply the concept of relative velocity in case of speed of light. Then whenever we see a photon moving, then photon always moves with the speed of light, and the speed of the photon will not depend on the observer, whether observer is at rest or observer is moving. It will remain same. Very important point is saying that this is true for any frame of reference to observe the photon. Frame of reference means from where it is observed. Observer location is called as frame of reference. Now, second point, I am going to elaborate it. Photons are electrically neutral particles. Photons have no any charge, neither negative charge nor positive. So when it moves in an electric field region or in magnetic field region, it will not deviate at all. They are not deflected by electric or magnetic field. Photons are not material particles. They are tiny packets of energy. With change in momentum, speed and wavelength, the photon, with change in medium, speed, wavelength and photon frequency does not change. What he is saying, photon has no any charge. Photon has no any charge. If photon moves in a region where electric field is present or in a region where magnetic field is present, then there will be no effect on the motion of photon. It will not be affected. When moves, suppose there is a medium separator, this is called as interface. Suppose there is one medium and the second medium on the other side, and photon moves from one medium to other. Then medium M1 is changed to be M2. Then speed, wavelength said that speed wavelength, suppose here is speed v1 wavelength lambda 1, then here is speed v2 wavelength lambda 2, or there is a frequency, one term frequency of the photon will not change. Suppose one photon moves from one medium to other medium, then its speed will change, its wavelength will change, and its frequency will not change. It has been asked in one time AIEEE examination, JEE main examination. Which property of the photon remains unchanged when a photon moves from one medium to other medium? And that property is known as frequency. Frequency of the photon will not change. Speed can change, may change, wavelength may change, but frequency will. Now, next point. The mass of photon is not defined in the sense of Newtonian mechanics. As we have studied in mechanics, mass, there is a mass, but we never define the mass of the photon. We shall ignore this concept. We simply state that rest mass of the photon is 0. What does it mean? Suppose photon, it is at rest, then its mass will be 0. Mass will be 0. When photon is at rest, then its mass, it is when it is moving, we will not talk about the mass. Say there will be some mass, but we will not talk about the mass of the photon. But when photon is stationary, its mass will be 0. Now next property. This relation is very important for photon. And photon is not a material particle, rather than its bundle of energy. And each bundle has energy E is equal to h nu, where h is Planck's constant. Planck was a scientist. Planck's constant. And nu is the frequency. Okay? And energy can also be given at hc by lambda. Now, there is a relation, frequency is equal to c by lambda. This relation sometimes, if wavelength of the photon is given and asking the frequency of the photon, then you should know this formula. C is the speed of light. And this is the energy of photon. And momentum of photon is given as from h by c. And momentum of photon is given as h by lambda or E by c. E is the energy of the photon. This relation is very important. Energy of photon, one photon. I again remind you, photon is not a material particle, rather than its bundle of energy. And energy of each photon will be h nu. Nu is the frequency of light. Light, particles of light. Photons are the particles of light. Lambda is the wavelength of the photon. P is the momentum gained by the photon. E is the energy of the photon. C is the speed of light, the wavelength of the photon. H is the Planck's constant. Okay. Then these properties, I am going to take some next thing. What is saying? A photon may collide with a material particle. The total energy, total linear momentum remains conserved in such a collision. The photon may be absorbed, a new photon may be emitted, but the number of photons may not be conserved. He is saying that photon is not a material particle, but photon may collide with material particle. The total energy and total linear momentum will be conserved in a collision, such a collision. But sometimes photons are absorbed in any material, sometimes it is emitted from any material. The number of photons are not conserved. If the intensity of light of a given wavelength is increased, then there is increased number of photons crossing a given area in it. What he is saying, I am going to tell you this very important phenomena. Number of photons proportional to intensity of the light. Right. Suppose there is a area and one bulb is glowing here, one bulb is glowing here, emitting light. Then some photon will cross through this area. If we double the bulb, there are two bulbs, then number of photon will pass as in the previous case. Intensity, number of source, number of light source. Or if some light source is away, suppose this is light source and it is away from this area, and some light source is very close to this area, then the light source which is nearer to the area, then number of photons passed from the light source nearer will be more. What we simply say, there are any light source, that light source will emit photons. If there is only one light source will be emitted, two light source, more photons will be emitted. Again increase the light source, three light source, more and more photons will be emitted. And if we decrease the distance of any light on which they are projected, then also the number of photons crossing that area will increase. But one thing is important, wavelength of the light should remain constant. Wavelength means if we are using blue light, then its wavelength will be different. We are using red light, its wavelength will be different. We are using violet light, its wavelength will be different. Use one kind of light and simply increase its intensity, then passing the given area will increase. Okay guys, then these are the some properties you are required to mug up the things. I'm going to take some more. Matter waves. What is matter waves? See here. How this idea came about matter wave. In 1924, French physicist Principal Louis de Broglie, pronounced as de Broglie, made a remarkable proposal about the nature of matter. His reasoning, freely paraphrased, went like this. Nature loves symmetry. Light is a dualistic in nature, behaving in some situations like waves and the other is like particles. If the nature is symmetric, this duality should also hold for the matter. Electrons and protons, which are usually think of as particles, may in some situation behave like waves. First times, de Broglie, there was a person, French science physicist, in 1924, thought that our nature is symmetric, such as planets moves around the sun in a circular orbit manner, electrons revolve around the nucleus in the same manner. It was thought by the Rutherford symmetry concept. Then de Broglie also thought that nature, and if light can have dual nature, it may behave in some situation as a wave, in some situation as a particle. Then, since nature is symmetric, every particle should behave like wave as well as particles. Every particle should have dual nature, particle nature as well as wave nature. This idea was traveling in the mind of de Broglie. According to de Broglie, what he has concluded, what he has given the theory. According to de Broglie, a moving material particle sometimes acts as a wave, sometimes acts as a particle. The wave associated with the moving particle is called matter wave or de Broglie. Matter wave is not very dangerous wave. Simple. If someone has moved from here to here, then we probably say that he has moved in this wave nature. He has moved from A to B in a wave form. Then sometimes its particle nature will be dominant and sometimes its wave nature will be dominant. Every matter which are moving have dual nature. Sometimes its wave nature will be dominant and sometimes its particle nature will be dominant. And since the particles act like a wave, it should have wavelength and frequency. This was the basic idea he had thought. And he told us, I'm going to tell. Even some relation regarding the dual nature of matter. De Broglie used this relation. This relation was given by Planck's, and E is equal to mc square. This relation was given by Albert Einstein. Then de Broglie said that this relation can be applied for any particle of the universe. I again remind, this relation can be applied to any particle, to all particles of the universe. Lambda is wavelength of the particle. P is the momentum. P is equal to mass into speed, mass into velocity of the particle. H is the Planck's constant. Then this is very important. I am going to take some conclusion regarding that conclusion. What I am going to tell you. This, remember, this is very important. Lambda is equal to h by mv, h by 2 mk. K is the kinetic energy. V is the accelerating voltage. Q is the charge. T is the absolute temperature. And from this relation we can solve it. I am going to explain something. Lambda is equal to h by p. This is the basic relation given by de Broglie. Lambda is the wavelength and p is the momentum. S is the Planck's constant. Now lambda can be written as h by mv. Momentum is given. Since we know kinetic energy can be given as half mv square, now it can be written as half mv whole square by m. Multiply inside, we will get this relation. mp can be put at momentum. Now momentum can be written as twice mk. This is the relation between kinetic energy and linear momentum. K for kinetic energy of the particle, P for momentum of the particle. Okay. Now I have done this. Now I am going to take this. Suppose we want to accelerate a charged particle. There is a charged particle Q. We want to accelerate, to run this charged particle towards here. And we have to apply the accelerating voltage. And this accelerating voltage into charge is equal to, when charge is running, then its energy will be in the form of kinetic energy. This is very important relation. And this is kinetic energy K. Then in the place of K we can write QV. That is why this relation. Then it's very important. Now I am going to take some problem. Those relations, one important thing I am going to tell you, those relations which has c, that is speed of light, are only valid for photon. For photon. Because with such great speed, no particle can travel, neither electron, nor proton, nor neutron. Then in any relation, if there is E is equal to PC, E is equal to PC, we found that this relation contains C. Hence, we conclude that it will not applicable to electron. It will only be applicable only for photon. Third option will be correct for photon, but not for electron. But de Broglie relation H is equal to H, but de Broglie is equal to H by P. This is valid for all particles of the universe. For electron, for proton, even for photon, every particle of the universe. But speed containing expressions are true only for the photon. There is a one more term E is equal to mc square, valid only for photon, and E is equal to sc by lambda. This relation is not valid for electron, valid only for photon. This is very important. But this relation is true. In fact, this relation has been equal to mc square and A is equal to hc by lambda. Now equate these to mc square is equal to hc by lambda. Cc cancel, the mass into speed will be momentum, h by lambda. Lambda is equal to h by p. De Broglie derived this relation only for photon, but due to symmetry, he said that there is symmetry in the universe. Only due to that reason, this will be applicable for all particles of the universe. Though it has been derived from the photon equation, but this is the only was awarded the Nobel Prize. He said that this equation is derived from the photon equation, but this equation can be applied to material particles too, like electrons, protons, human beings, ball, cricket ball, tennis, to any car, moving car. But those expressions which are valid only for photons, and de Broglie relation is particle of the matter. This was the duality nature. This was the symmetric nature in the universe. Now I'm going to take the next question. P and D denote the movement energy of the photon. Energy of the photon is given as Sc by lambda, and linear momentum of the photon is given as h by lambda from the de Broglie. What is saying? Is saying that wavelength is decreased, then energy will increase. Wavelength is decreased, then momentum will increase. Both P and E will increase. When wavelength decreased, both P and V will increase. Very simple. Next question. Guys, copy it. Then I will proceed for the next question. जी सर बताइए. वालेकुम सलाम, बताइए सर। किस सब्जेक्ट का? दोनों? कितने में यार? ठीक है, 15 15 मैंने 30 में। अच्छा, पैसा कितना दिया अभी? चल, चलिए बहुत बढ़िया काम किया सर आपने। हाँ, कर दीजिए कर दीजिए। हाँ तो बाद में मिल जाएगी, कल कल लेते आएंगे एक एक पीस। ठीक सर। हाँ बिल्कुल बुला दीजिए सर। बराबर बराबर। नहीं, उसी में बुला लो, दोनों में जो चल रहा है। नहीं नहीं, कल एक काम करिए ना, कल इनको बुलाइए 10:30 बजे, जो छूट गया है ना वो पूरा हो जाएगा फिजिक्स में। हाँ हाँ कल। ठीक। Now, guys, I'm going to move for the next question. Which of the following is not the property of photon? Photons are not deflected by electric. It is true. All photons of the particle have same energy. Energy of photons is by lambda. If a particular light is thrown, particular light is focused, then each photons, there are infinite photons, billions, trillions photons. Every photon has same energy. This is also true. Photons always twice the speed of light in a vacuum. This is true. With change in medium, frequency of photon change. This is wrong. And he is asking that which are the not the property of photon. Photon की property कौन सी नहीं है? Then this fourth is not the property of photon. When we change the medium, then frequency of photon will not change. Speed changes, wavelength changes, but frequency of photon will never change. Okay. Now I am going to take the next question. What is the de Broglie wavelength of an electron in the first Bohr orbits of hydrogen atom having perimeter P? Guys, from the Bohr's quantization rule, we know that MBR is equal to NH by 2 pi. And for first orbit, we will take n is equal to 1. This relation was taken from the Bohr's quantization rule. Okay. Now, MB can be written as h by 2 pi r. This is the radius circumference of the orbit. This is the momentum. Momentum will be h by capital P. And from de Broglie relation, momentum is equal to h by lambda. Compare these two relations. Compare. Then lambda will be equal to P. P is the perimeter of the orbit, first orbit. This will be the correct option. It's very easy. This requires a certain knowledge of Bohr's hydrogen atom. For Bohr's hydrogen atom, MBR will be equal to NH by 2 pi. MV means momentum, mass into velocity. H by 2 pi R. R for 2 pi R for perimeter. This is the perimeter. And from the de Broglie relation, we can compare lambda is equal to P, that is perimeter. Wavelength. He is asking about the de Broglie wavelength. Copy this, then I will proceed for the next problem. Now, guys, my next problem will be this. Suppose you have to solve this problem. The ratio of de Broglie wavelength of alpha particle and protons have been accelerated to the same potential difference. I have read some formulas, and that formulas are this. Lambda is equal to h by 2m qv. Lambda is equal to h by 2m qv root. This is the formula of de Broglie wavelength, where lambda is wavelength, h is Planck's constant, mass of the particle, q is the charge of the particle, v is the accelerating voltage. And there are two particles, alpha particle and protons, which have been accelerated through the same potential difference. V is constant, h is constant, and lambda will be proportional to 1 by root mq. Then for lambda alpha, it will be mass of the alpha, charge of the alpha. For lambda proton, will be proportional to root of mass of the proton and charge of the proton. Divide these two, lambda alpha by lambda proton. It will be the ulta relation, reciprocal relation will be there. Mass of alpha, charge of alpha. This is alpha. This is the relation we have got. Now this question requires some knowledge about the alpha particles, beta particles. Mass of the alpha particles is approximately 4 times mass of the proton, because alpha particle is nothing but doubly ionized helium atom. Helium atom may say there is a nucleus and 2 electrons are rounding. These are 2 electrons, and 2 protons, 2 neutrons are there inside the nucleus. Remove these 2 electrons from the atom, then we will get helium plus plus. This is alpha particle. Then we are left with 2 protons and 2 neutrons. Neutrons are slightly heavier than protons, but approximately their masses are equal. But one thing should be noted, neutrons are slightly heavier. Then 2 protons, 2 neutrons, approximately 4 mass of the protons. This is the mass of the alpha particle. And charge of the alpha particle will be plus 2e. When 1 electron is ejected out, charge will be plus e. 2 electrons are ejected out, charge will be plus 2e. And other thing we know, we can write this relation, mass of the proton, mass of the charge of the इलेक्ट्रॉन प्रोटॉन इज ई, मैग्नीट्यूड ऑफ द चार्ज, अल्फा पार्टिकल का चार्ज ये होता है, मास ऑफ द अल्फा पार्टिकल 4 mp होता है. दिस कैंसिल, ई कैंसिल, 4 2 जा 8, विल गेट 1 by 2 root 2, 8 का स्क्वायर रूट. The correct answer will be this. Then please copy it, and this requires minimum knowledge. You should consult your physics teacher to know the mass of the alpha particle, mass of the beta, mass of the proton, charge of the alpha particle, charge of the proton. It's a very easy question. Copy this, then I will proceed for the next question. now guys, we are going to for the next question. We are moving for the next question. This question was asked in ITJ. It's very easy question. Very easy question. Potential energy of a particle is given like this. Between the interval 0 to 1, potential energy is E naught. Between the interval this, potential energy is 0. Its total energy of the particle is this. This is the total energy. Now we can compute between 0 to 1 potential energy, denoted by the symbol U. Potential energy is given as E naught. Total energy to E naught. Kinetic energy, total minus potential, we will get 2 E naught minus E naught. For the interval x greater than 1, potential energy is 0. See here from here. And total energy is 2 E naught. Then kinetic energy, suppose this kinetic energy is K1. So 2 E naught minus 0, it will be 2 E naught. Okay. Now in first case the de Broglie wavelength is lambda 1, in second case that is lambda 2. He is asking the ratio of the wavelength. Then we know the guys, wavelength is given as h upon root of 2m k. K is the kinetic energy, I have told you. Then lambda 1 by lambda 2 will be equal to root of k2 by k1. And guys, see, k2 is 2 E naught, k1 is E naught. 2 E naught and this is E naught. It will get cancelled. The answer will be root 2. Then this is very easy question. The answer will be root 2. Potential energy is defined by breaking into two parts. So copy this, guys. Then and practice the DPP which I have given to all of you. And this is very easy topic, and one question will certainly be asked in your AIEEE, JEE Main and JEE Advanced examination. Okay guys, ठीक है, आज के लिए इतना ही, बाकी अगली सभा में।